A wonderful example of how to really stuff things up requires an academic. I'm going to be slightly uncomfortable. I don't normally stand at lecterns, and I normally change the slides remotely, so forgive me while I get organised. It's a pleasure to follow that elegant lecture by Chris, and thank you, Chris, for a really super summary of, and what's more, a low temperature summary. That's what I so admire about Chris's presentations. One of the things about climate change is there's about 100 or more sub-disciplines. There's no such thing on the planet, not Christopher Freitas, not Richard Lindzen, and not me, as an expert in climate change. The animal doesn't exist. All of these people are experts in one or two out of up to 100 disciplines that are relevant. So all of us then end up at lecterns like this, talking to groups like this, and often I have to talk about atmospheric meteorological things on which I'm not an expert. In other words, I'm talking about stuff I don't know what I'm talking about. Lots of people in the world are very happy to point that out, I might say. But I do it because I think there's an urgent need for it. Today I can relax, and it's unusual for me to be able to talk about what I really do research in, and that is sea level change. So this is a bit of a different talk for me. I'd normally follow on Chris's talk with some more detail about change through time, climate change through time. Why sea level? Well, because we're in Sydney. And I was delighted for Christopher to say he doesn't believe in technological solutions to anything. Doubtless the good burgers of the Sydney North Shore would take a bit of an exception to that, because of course we have that wonderful piece of engineering that allows them to come over to the city, Sydney Harbour Bridge. The picture we're seeing here is another bridge in Auckland, and my first and last slides are organised around the same thought, and the thought is, this is what the ordinary citizens are being presented with. This is what they're being led to worry about. I will show you in this talk it's completely irresponsible, but let's start with that focus. Okay. We need context. And the context is this. I've chosen just to take the last 20,000 years, 20,000 years there, and 0 today here. So, and this is sea level. And the scale is 120 metres sea level fall just 20,000 years ago. Now many of you know what that was. That was the peak of the last great glaciation. That's when the Aboriginals walked across Bass Strait to Tasmania, and the Torres Strait Islanders walked across Torres Strait between the islands. So that's real environmental change. It happens, and our planet is a dynamic planet. We have to, any public policy we set on these matters has to be against the background of understanding the context of natural change. So on this diagram, it's sea level change. Well, hang on, how did you get that? You weren't there. How did you theodolite in this sea level of 120 metre change in the last 20,000 years? Well, the answer is all these dots along here are different, keyed out, the details don't matter, different places in the world where geologists have studied and reconstructed points on that sea level curve. And I'm going to show you how they do that. But before I do that, two other things I want to make out here. Firstly, this is global sea level. It's called eustatic in the trade. That's a global average sea level. And just like global average temperature, which is the basis for so much of the alarmism in the press, it has no meaning in terms of you as a citizen living out on Bondi Beach. You couldn't care less what's happening at global sea level. What you want to know is what's happening at Bondi sea level. And if the average global sea level is this, then every place in the world, most places in the world, will have either a higher or a lower rate of sea level change than that, because the average is just the average. It's statistic. It has no real world meaning. You can't drive real policies and real engineering solutions, sorry Chris, we have to have them, based on statistics. They have to be based on empirical data on the site. So what I'm talking about here, and all the public discussion on the sea level issue, is based around this notional average sea level. Well, for goodness sake, if you're an architect in Jakarta and a client asks you to design a house, you design the heating and the air conditioning systems for Jakarta. And if you live in Finland and you're an architect, you design them for there. If you design them for a world average temperature, you won't be in business very long. I mean, this is pretty obvious stuff, isn't it? Yet the whole of the public discussion is based around this lie, and it is a lie, or misjudgment. And before I leave this, the last thing I want to do in context is just point out these 2 points. Up here, when the glaciers were melting very fast, the ice caps moving fast, the rate of sea level rise was up to 1 to 2 metres per century. 100 to 200 centimetres per century. That's, if you like, a natural maximum limit. You can't melt big ice caps faster than that. But over the last 10,000 years period, this warm period in here called the Holocene, that Christopher's referred to, when our civilization grew up and we live at the end of it, the rate of rise is very much less. It's 20 centimetres per century, which is 1 to 2 millimetres per year. So that's the sort of change we're thinking. That's the natural change in the global average sea level. Okay, so how do we get to the points on this graph? Well, there's a number of ways we do it. This is Balding Bay, just offshore from where I live in Townsville. And around the edge of the bay, we find this oyster bed. And the oysters, it's quite strictly tide delimited. The top of the oyster bed runs along there at about 0.4 metres above Australian height datum. And there you can see it's quite a sharp indicator. Now, behind this boulder here, if we go around the back, we find a fossil oyster bed. And if we level that in, we find it's around 2 metres above Australian height datum. And when we date the fossils by radiocarbon dating in here, we get a date of around 5,000 years before the present. Now, these are just simple scientific facts, but they're pretty mind-boggling when you start to think about them. What this says is that just 5,000 years ago, sea level at this locality was about 1.5 metres higher than today. Innocent fact, you might say, but nonetheless a fact. And sea levels settled back, as we'll see, to today's level over the intervening few thousand years. If we now look at one of the famous fringing reefs around the Great Barrier Reef, if you're lucky, this is around one of the islands near shore. They look like this, pretty verdant. But in amongst here, you'll have individual coral heads, and here is one, of this particular shape that is called a micro-atoll. And what's happened is that a coral, a hump-like coral, has grown up towards sea level, and of course it can't grow above the average sea level. So what happens is it grows outwards in sort of a mushroom shape, and the middle bit dies. So this is as sensitive an indicator, plus or minus 5 centimetres, of mean sea level as it's possible to have. If we look at these fringing reefs, a lot of them look like this. There's virtually no living coral on them at all, but here are these huge subfossil micro-atolls. Well, that's really neat. This is oyster beds, this is fossil corals now, something totally different. And so we can date, and this is lovely work from the Australian National University back in the 1980s. If we date profiles across the, I apologise to people on this side of the room, but I can only point one way, so I'm pointing on this screen. If we look at these, you find the oldest dates are always back here, slightly higher than modern sea level, against the mangrove flat, and the dates get progressively younger, and the living micro-atolls are out here at the modern low tide level. So clearly again, this is telling us, just like the oyster bed, sea level's fallen over the last few thousand years. And here's the graph that summarises that. Go back to 6,000 years ago. Here with the error bars are the micro-atolls. Here up is the Balding Bay oyster bed. And you see overall we've got a sea level drop of around 1 metre or 2 over the last 5,000–6,000 years. This isn't global sea level. That's just local sea level on the Great Barrier Reef coast. Well, now we might go out and have a look on the continental shelf. So here's modern sea level. Here's the edge of the continental shelf. That'll be at about 120 metres depth. And here's today's shoreline system with a barrier island and a bit of an estuarine region behind it. And we've been looking at micro-atolls and oyster beds around here. Now, John just go out and they look at the seabed out here, and we find down here at 120 metres depth things that look like this. This is a real seismic profile. Here's the depth scale, 80, 100, 120 metres, and you can see this wedge of sediment which pinches out against the shoreline at about a depth of 120 metres. And when we sample that, by taking a core through it, we find we have well-sorted sands, estuarine muds, but at a depth of 120 metres on the modern seafloor, and mollusks, whelk shells, which today live on sandy beaches, get washed up at low tide zone on sandy beaches. And when we date these, we get a date of around 20,000 years ago. Because that's where the shoreline was 20,000 years ago. Sea level dropped, all the water came evaporated out of the oceans, down onto the ice caps, and sea level dropped and the shoreline migrated. So this is a last glacial 20,000-year-old shoreline. So that's another point on the sea level curve. You saw what I could do with plugging something in the computer. You imagine what I can do to Jim's computer with a glass of water. Okay, so now, following on the theme, we've looked at shoreline indicators, we've looked at fossil shorelines in water depths of 120 metres, but now we're 30 metres up on the edge of the Norwegian fjords here, and here we've got beach ridges, which again are made of shells that live in the intertidal zone today. But here they are, 30 metres above sea level. What's going on here? Well, obviously, we've had uplift. And here's the summary. Oh, God, what's going on there? The locality is up here, right in the north of Norway, and it's at about 30 metres above sea level today. And these contours are actually contours of uplift in the last 6,000 years, second half of the Holocene. And what you see is that this is only 30 metres of uplift, 40, I can't quite read the number, 60, but in here is 80 or 100 metres of uplift in the last few thousand years, because again we radiocarbon date these shells and they're about 6,000 years old. So what's going on here? I mean, we can understand having sea level indicators, intertidal indicators, 120 metres depth if sea level fell 120 metres, last glaciation. But these shells were only deposited 5,000 years ago, and they, where they are, 30 metres above sea level, potentially in here they could be as much as 100 metres above sea level, and some other examples are. What's going on? Well, what's going on is, Mr. Gore needs to know about this, we live on a dynamic planet, and that dynamism is geological as much as it's biological or meteorological. And if we go about 100 kilometres down into the Earth's crust, you all know it gets hotter, and ultimately in the middle of the Earth we have a molten centre. But as it gets hotter, there's a level at about 100 metres down which approaches the melting point of solid rock. And what happens is the rock melts, but only around the edges of the grains. And what that means is it doesn't act as a solid rock, it acts as a plastic. And what plastic does is it yields to flow. So what you're seeing here is the effect of having had a big ice cap sitting there 20,000 years ago, and that depressed the Earth by a process called isostasy, and then you take that load off, you melt the glacier away, and the substratum will quite naturally just rise back up again. It's simple old Archimedes principle. It's like having a cork in the bath, basically, pushing it, but it just takes a little bit longer. It takes, on the timescale of geology and the rate of flow in this plastic layer, it takes hundreds to thousands of years for this to occur. Okay, well, what that means is that wherever we go in the world, we have a different local relative sea level change. Sure, you can have a worldwide average, but let's get real. We want to worry about what should we do at Bondi Beach. And that relates to which bits of the world are responding to these moving loads of ice. And when you melt the ice, you put water into the ocean, the addition of that water. So if we take a model now, and this is the model that fed into the model, is a sea level rise, the last bit of melting of the glaciers up to this point, and then no change in sea level for the last 5,000 years. Then these are the different zones of the world and the way they react. And if we look at this one, under the Greenland ice cap, the sea level curve we see is that there has been a steep drop in local relative sea level over those 5,000 years because we melted the ice off, the shoreline's sitting there, and now the substratum rises, as we just saw on that map of Scandinavia. And so this is the local relative sea level curve over the last 5,000 years. If we come somewhere like Australia and New Zealand, which is what is called a far field, well away from either of the big ice caps, then what happens is that local relative sea level curve, this is the eustatic, the global change, but the local one rises to the modern level, it overshoots it slightly, and we've now put a load of water on the edge of the continent. So what does it do? It gently subsides. And as it subsides, the sea level just gently falls a metre or two. Remember the microatolls? Remember the Balding Bay oysters? That's what that's about. That's called hydroisostasy. It's the response of the flexible earth underneath to these shifting loads. And finally, large parts of the Northern Hemisphere, the North Atlantic, both coasts, they're intermediate between the far field and the polar ice-loaded areas, and they show this gentle asymptotic sea level rise up to the modern level. So horses for courses. It depends where you go as to what the local sea level curve is actually doing. Most difficult graph of the lot, but really worth trying to understand. This is a plot of 4,000 dated intertidal sea level indicators from all around the world. And consistent with what I just said, the real world data shows that in some places there'll be a point here, 10,000-year-old shell that was deposited on a beach, which is today sitting at 100 metres above sea level. Somewhere else in the world there'll be a shell of the same age, which is sitting 30 metres below sea level, depending upon what the local uplift is. Now, if we plot on this, note the scale, it goes from 0 here to almost the last glaciation here, almost 20,000 years, and here's today's level to reference, that's sea level today, then that's where sea level was at the last glacial low stand. So what's happened between 20,000 years and going today is that approximately the eustatic sea level curve has risen along the green curve there. As the ice melts, the water goes into the ocean and the ocean level rises. Let's now take a point, just one of these ancient fossil points, that's 60 metres above sea level today, but it's a shell that lives intertidally. So it lived on the green curve down here. That's where it actually was deposited, but it's been uplifted 40 plus 60, so there's 100 metres of uplift of this particular sample over the last 5,000 years because of the isostatic rebound. This will be one of the examples from probably Norway or somewhere like that. Okay, meanwhile, what that means is we've had uplift of 100 metres in 10,000 years. So that's an uplift rate of 10 metres per 1,000 years. That's the underlying geological uplift rate. And that underlying uplift, which is more or less steady, has to be combined with the curvilinear rising eustatic sea level due to the volume of water in the ocean increasing, and the result is here is the local relative sea level curve for that point. And every other point on the diagram has its own particular local relative. How misleading is it to try and set public policy in terms of an average global sea level? It is literally insane in scientific terms. Okay, well, so much for the theoretical background. I'm sorry, that's slightly heavy stuff, but you do need to think about it. Let's now come to real-world measurements. So the way we measure sea level traditionally is tide gauges. A modern tide gauge looks like this. Following Chris's example, using the IPCC as a guide, this is their diagram of 4 of the world's most reliable tide gauge data sets. And if we look at the last 100 years, we see a general increase, leaving out the short-term annual variability. There's been a general increase, and that increase is going on at a rate of between 10 and 20 centimetres per century. That's 1 to 2 millimetres per year. So that's the background global eustatic sea level rise that's going on. There's another way, and of course it involves computers and satellites, of measuring sea level. And this curve is only available since 1993, and that's because that's when this first TOPEX satellite was put up. And this sea level change, again, if you take out the short-term variability, you fit a line through it, you see that between 1993 and 2010, the rate was 2.8 millimetres per year. Now that's over twice, or about twice the rate that I just said the tide gauges measure. So what's going on here? These are 2 different methods of making measurements. Well, the tide gauge measurements are made with respect to a level benchmark, intertidal benchmark level in every country of the world. These are different. They're not made they're made in terms of radar altimetry. A radar beam measures the distance between the Earth's surface or the sea surface that it bounces off and returns signal to the satellite. But in processing the data, the benchmark is a model of the shape of the Earth. And the Earth isn't a sphere, it's an oblate spheroid, technically. And so that's a mathematical model. And we don't know that precisely. There are different models you can use. Also, it turns out, the shape of the Earth changes slightly through time. So, caught up in here, and the reason for probably the double rate of the tide gauge measurements is the fact that we have to cobble together the results from about 8 different satellites. You can imagine the amount of statistical... This is Christopher Freitas' dream data set. The amount of statistical jiggery-pokery, in a nice sense of the word, that's gone into assembling it is amazing. But they do get a record, and the people that do it, to the best of their ability, this is their estimate. It turns out to be about twice the rate at which other indicators suggest sea levels changing. Now, if we go back, you'll see that this curve actually was rising at a higher level, in fact around 3.2 millimetres per year for most of this period of time. The last few years, it's actually levelled off. So now we've only got 2.8 if we fit a line. The question is, why would you fit a straight line through data that you know is sinusoidal? And this is something that climate scientists do the whole time, excepting the honourable exception in this room. The IPCC spends its entire life fitting straight lines through data that we know are not straight line data sets. But the argument is made that this rate of sea level rise here, because it's 3.8 before those last few years, it was, sorry, not 3.8, 3.2, and because we know historically the tide gauge level is about 1 to 2, then sea level rise is accelerating, chaps. You politicians, Corey, you've got to do something about this. So that was the argument. Well, the real argument is let's fit a proper curve, a spline curve through this data set. There it is. And irrespective of the fact that it's not absolutely accurate, we don't actually believe the 2.8 figure, it's more likely to be 1.5, leaving that aside, the shape of the curve is very clearly decreasing. There is no possibility whatsoever of an increase, an acceleration in the rate of sea level rise at the moment, using the best, most sophisticated data set we can collect. Okay, well, here's one of the IPCC's projections. This is their sea level projection, and there's a number of different things taken into account: melting ice, expansion of the water of the ocean. As you heat it, the water expands, sea level rises, and these are envelopes of different calculations. The bottom line is that the IPCC suggests in the next 100 years, out to 2100, we will have between a 20 and a 60 centimetre sea level rise. Now, if it's this, the question has to be, so what? What's the problem, chaps? I mean, that's what we had in the last 100 years. Did you notice Sydney being inundated? So, but nonetheless, so that's their model projection. So there we are. We've now plotted that on a different graph. Here are the historical tide gauge measurements. If you project that rate of 1 to 2 millimetres per year out to here, you get your 20 centimetres rise, which coincides with the lower level of the IPCC's estimate. So, what's this red line doing here? Well, that red line there is an article by the Royal Society of New Zealand, a very prestigious body, a paper about 2 weeks ago, where they advised the New Zealand government that they need to plan for a sea level rise of 1.5 metres, 150 centimetres. Well, I mean, you know, this is cousins over in Tasman. We all know they're a bit slow. Nonetheless, we're doing our best to catch up with them. Victorian government has an 80 centimetre and New South Wales government a 90 centimetre. This is already enshrined in local council planning law. It is a total scientific scandal. Byron Bay, that has a green-controlled council and mayor, is threatening property owners with 140 centimetres, and our old friend Jim Hansen from NASA, who's viewed as the world's leading climate scientist, you can see why he's the leading scientist. He's the furthest out in the left field, he's so far out in the left field you can't see him over the horizon. He thinks there's going to be 6 metres of sea level rise by 2100. These are just ridiculous, irresponsible projections. But they are the projections that the politicians in this country and the city councillors have nowhere to go. If the state government legislates and the federal government legislates, the councillors have no other thing to do but apply those rules. Well, how should we deal with this? The first thing we've got to do is take a dose of reality. Storms and beach erosion happen, chaps. Get used to it. If you bought a condominium on the shoreline, one of your risks is you're going to lose a bit of the front of your property when nature does her thing. Here's a big storm in 2009 that hit New South Wales and the Queensland coast. Ripped several metres of sand off the Gold Coast beaches, and the damage bill could hit $40 million. Nothing unusual about it. There's nothing to be alarmed about unless you happen to own one of these beachfront high-rises, and silly you for building it there. But this is just nature doing her thing, and we have to learn to live with that, not try and stop it. Have you ever heard of a politician saying they're going to stop a volcanic eruption? They're going to stop an earthquake. Yet people actually believe they're going to stop sea level change, and they're going to stop climate change. This is just absurd stuff. And it's become about because of a huge propaganda campaign which has had a huge impact on public opinion, and that feeds back to the politicians. Bondi Beach. Sunday Telegraph 2007, Australia's most famous beach could be reduced to a boardwalk by global warming. Bondi Beach would disappear under rising sea levels. The action group, Get Up, for the APEC conference in Sydney, did this stunt. It's all about getting on television news, that's all it's about. There's no scientific basis for this whatsoever. It's let's go down to the beach and have a bit of a play with a flag and see if we can get the telly crew to film us. That's what's going on. Penny Wong. Speech in Adelaide in February. Australia's most iconic beaches. Note the choice. Bondi Beach, Bells Beach, and those of the Sunshine Coast. Hits every button. Could erode away or recede by hundreds of metres over the coming century. And she said in this speech, another claim made by the global warming skeptics like me and Ian Plimer and so on, another claim is that the IPCC exaggerated economic losses from catastrophes attributed to climate change. The science on the link between these catastrophes and climate change has not been credibly challenged, says our former minister. Hasn't it, Minister? Here we go. Here's the graph. This is the amount of insurance losses, just plotted as raw data over the last 100 years or so. And here it is when you normalise it for the fact that more people go and live on the beach today, we have more property exposed to these risks, and you normalise the risk. And there's no trend there whatsoever. In fact, the last few years, we've been losing less. Paper by Crompton McKinney in 2008. Once the weather-related insured losses are normalised, they exhibit no obvious trend over time that might be attributed to other factors, including human-induced climate change. That paper's written in 2008. We have a federal cabinet that gets up in public and gives a speech in 2010, flatly ignorant and indeed contradicting the latest and best science. That is a problem, because I've just given you one example. It's symptomatic of what's going on right across the board. The advice that's going into government on technical, scientific and engineering matters today is no longer unbiased, balanced advice. It's advice that the people giving it view as politically acceptable. The politician is told what politician signals they want to hear. That's not the way science works. It's not what I do. It's not what Chris does. It's not what Ian Plimer does. Oh, well, of course, there's an icon we have to have. This, isn't there? We're at Sydney Opera House now. At risk from climate change and sea level rise. Well, here's the sea level curve measured with good tide gauge for Sydney Harbour in the last 100 years. 1 millimetre per year, 10 centimetres. About half the global average. So here's the effect. Think it's going to make a big difference? It's actually less than that thickness of that red line, is how much the sea levels are going to rise around the Opera House. But note the choice. Bondi Beach, Bells Beach, Sunshine Beach, Great Barrier Reef, Kakadu Park, Murray-Darling Basin. These are all emotional hit buttons which relentlessly, day in, day out, the Australian media and the politicians that milk the media hit. Science, out of sight, not even in the race. Tom Calmer is a distinguished Aboriginal who chaired a commission which produced this native title report in 2008. In it he said, anecdotally, are we setting public policy on the basis of anecdotes these days, aren't we, Mr. Calmer? Islanders have voiced their concerns to me about the impact of climate change and the visible changes already occurring, such as increased erosion, strong wind. All of those, of course, are perfectly natural, everyday weather events. Worse, there's Masig Island. Here from the report is an aerial photograph of Masig Island and a projection of Masig Island in 2100 under the rising sea level that is going to inundate it. In fact, if a big cyclone went through Masig Island tomorrow, it would actually go right over the top of it. But you can imagine how the general public react to this sort of scaremongering. It is pure scaremongering. And it's outrageous that this is being incorporated in distinguished reports being tabled in both our Houses of Parliament. And it's happening across the board. Well, Byron Bay. I said I'd finish with the same thought that I started, which is the alarmism that's intrinsic in all of this. I started with Auckland being flooded by sea level rise. Here's Byron Bay. They've got a beach erosion problem there, they sure have. And they've got an even bigger problem, which is a local council controlled by the Greens. Byron Bay Mayor Jan Barham has copped a lot of flack, I'm pleased to hear that, over her Shire's handling of coastal erosion, but she's not relenting. In fact, she believes the latest science means council will have to take an even tougher approach. Greens Mayor told Climate Run that council will consider factoring a higher level of sea level rise in its coastal planning, and this is at 1.2 to 1.4 metres that I plotted on that curve we looked at before. The take-home message is this, and it comes from the non-governmental international panel on climate change report, a group of scientists who wrote a riposte, an alternative view of the climate change issue, including sea level, to comment on the fourth report, which was published in 2007 of the IPCC. And what they said was this: most discussion, including that of the IPCC, is formulated in terms of global average, that is to say, eustatic sea level. Even assuming this statistic can be estimated accurately, and at the moment our estimates from satellites are double the estimates from tide gauges, it has little practical policy value. Local relative sea level change is all that counts for purposes of coastal planning. And this is highly variable worldwide, depending upon the different rates at which particular coasts are undergoing tectonic uplift or subsidence. There is no meaningful global average for local relative sea level. That's got a clear policy message. And the policy is you have to adapt to local relative sea level rise as it happens. I have a book recently published, which I hope, the hotel sent them away yesterday, but we're hoping they're going to bring them back. I'll be able to sell you copies of it in the corner there. It's about not sea level, but about climate change in the broader sense. And it recommends exactly the same policy to dealing with climate change in the broader sense. To try and stop climate change or sea level rise is absurd. We need to adapt to those changes, prepare for them, we know they're coming, and adapt to them as they occur.